we will apply the concept of operations of functions to a topic that we've actually seen before. We will frame it in a different way, but we're talking about in this video simplifying a difference quotient. Recall that we discussed the average rate of change and defined it as the average rate of change of a function f on the interval x1 to x2 is defined as f of x2 minus f of x1 divided by x sub 2 minus x sub 1. And that this formula is really the slope of a secant line drawn through 2 points on the graph of a function f. Let's review. If we have the function f of x equals 3x minus 2, and we want to find the average rate of change of the function on the interval 1 to 5, we would find f of 5 minus f of 1 divided by 5 minus 1. Again, nothing more than the slope of the line through those 2 points. We get f of 5 is plug in 5 into the function, 3 times 5 minus 2, minus f of 1, plug in 1 in place of x to get 3 times 1 minus 2. And then divided by 5 minus 1, or 4. So the numerator, we get 15 minus 2 minus the expression 3 minus 2 divided by 4. The numerator is 15 minus 2, which is 13 minus 1, or 12, divided by 4, which is 3. Remind yourself that when we have a linear function, the slope of the line is the coefficient of x. The slope is 3. And that is the rate of change on a line. The rate of change is constant because between any 2 points on the line, the slope is the same. But we also see that same value coming out here. We get 3. Well, another way we can write this is using what we call the difference quotient. And it's just a different way to frame this whole concept. Here we let f of x, remember f of x is just another name for y, so f of x is 1 point on the function f. And for h a positive real number, so h is some number, we're going to add h to our x. So when we do that, we get a new value of x, which is x plus h. And then the corresponding y value at that point is f of x plus h. So don't let that notation confuse you. X plus h just represents an x value. The y value there is f of whatever that input was. And so then when we put this in terms of the slope formula or the average rate of change, we find the change in y, which is the f of x plus h, minus f of x, so that is the change in the y values of those 2 points, divided by the change in x. Well, our change in x is the x plus h minus x, but the change in x is just simply h, right? X plus h minus x is just h. So this is the difference quotient. And now we want to find the difference quotient for some functions. We have f of x equals negative 5x plus 3. So the difference quotient is f of x plus h minus f of x divided by h. To find f of anything, I'm going to do this down below. F of x plus h is we replace the x with what's inside, the x plus h. So this is negative 5 times x plus h, then plus 3. So this simplifies to be negative 5x minus 5h plus 3. And we already know what f of x is. That's our original function, and h is just some number. And so we would have f of x plus h, which we just found is negative 5x minus 5h plus 3. Then we will subtract off our function, so we need to put this in parentheses, negative 5x plus 3. And then divided by h. And then we simplify this as much as we can. Simplifying the numerator, we distribute the negative 1 So we get negative 5x minus 5h plus 3, then plus 5x minus 3, and divided by h. Note that the negative 5x plus 5x adds to 0, 3 minus 3 adds to 0. We have negative 5h divided by h, which we simplify to be negative 5. And if you remember, the difference quotient was this average rate of change just framed in a different way, which is really the slope of the secant line through the points on the line. While for a linear function, that is going to be the slope of the function, which is negative 5. Now what do we have? F of x equals x squared minus 3x plus 2. To find the difference quotient, we want to find f of x plus h minus f of x divided by h. So f of x plus h, we have to do a little bit more work to find that here, but remember that wherever we see the x, we're going to input the x plus h. So this would be x plus h quantity squared minus 3 times, there's the x, so we put in x plus h, plus 2. We have to square this binomial. Remember, we have to say x plus h times x plus h, which gives us x squared, plus 2xh plus h squared. If you need to, go back to the basics and do x plus h times x plus h and FOIL it out. Then we get minus 3x minus 3h when we distribute the negative 3, and then finally plus 2. And there's nothing else we can do because those are not like terms. So now we go back to our difference quotient, f of x plus h. We're going to put in this entire expression that we just found, which is x squared plus 2xh plus h squared minus 3x minus 3h plus 2. And now we have to subtract off, in parentheses, our function, which is x squared minus 3x plus 2. Then all of that's divided by h. So we get x squared plus 2xh plus h squared minus 3x minus 3h plus 2. Now distribute by negative 1 to get minus x squared plus 3x minus 2. All of that is divided by h. So now we get, let me clear off my screen for just a minute. We get, notice that the x squared, subtract x squared is 0. 3x, negative 3x plus 3x is 0. 2 minus 2 is 0. We have in the numerator 2xh plus h squared minus 3h, all divided by h. So notice that there is a common factor of h in the numerator. When we factor that out, we get 2x plus h minus 3, all divided by h. So let me repeat that. We have h times in the numerator 2x plus h minus 3, all divided by h. We divide out this common factor of h, and we're left with just 2x plus h minus 3.